So as we start to move into more complicated fractions that contain a lot of variables, we're still going to want to use those processes that we just talked about. And one of those processes is breaking things down into its factors so that we can simplify. Just like when we broke down what did we break down? 30? I think we broke down to 30. So when we broke that down, we're going to do the same thing. We still want to break it into its factors. And there are a lot of different ways to factor an equation. And the one that you choose, the method that you choose, is going to depend on the structure of your expression. So in this one, my structure tells me that I have an x squared, I have an x term, and I have a 3. So this is a trinomial, and I have an x squared and an x present. So I know what I'm going to have to do is break this into a pair of factors, or a binomial factor. Because this x squared is telling me that I'm going to have 2 factors, right? If I had an x cubed, I would have 3 factors. An x to the 4th would be 4 factors. Okay, so when you see that x squared, that's what you're going to have to do. And I have 3 terms, which is important. So luckily for me, on this one, I know that only 2 things multiply together to be 2x squared, which are 2x and x. Okay, and remember, in these, when I'm factoring, I'm trying to see what numbers multiply to be at the end here and what adds to be the middle. Okay, so 2 numbers that multiply to be 3. I also lucked out there, it's only 3 and 1. So it's either going to have to be a 3 here and a 1 here, or a 1 and a 3. Okay, and so I'm going to kind of strategically think about this. I know that this, when I distribute this out, I'm going to get 2x squared, and I'm going to get 2x times this number, right? So if I make a 3 here, that's going to give me 6, and that's really close to that 5. So we're going to try it first and see. So I'm going to try the 3 there and the 1 here. I have 2x squared. I have 2x times 3 would be 6x and 1x. 6 and 1 can give me negative 5 if the 6 is negative, which means this 1 has to be positive. Okay, and double check your signs. If I factor this out, I would have 2x squared minus 6x plus 1x, which would give me negative 5x, minus 3, which matches. Okay, so that's the most common way that we're going to factor a trinomial. The next thing to think about is ones that have, what if it didn't have that minus 3? And it was just like this. Okay, this is a different structure, but it still is going to give me 2 factors, right? Because I have that x squared. In this case, I don't have a 3rd term, so I can't use this process. What I'm going to think about instead is just if I can pull anything out that they have in common, or if they have a greatest common factor. Looking at the constants, 2 and 5 do not have a common factor. There's nothing that multiplies together to be both 2 and 5. So those are going to stay the same, but x squared and x, this is really x times x. So I can place that common one, they both have an x in common on the outside. Left over is 2 and 1 of the x's, and then minus 5. Okay, so that's another way to factor a squared. Okay, you could also do that if you had something that was higher than a squared, like a 4th or a cube, but you have 2 terms. Okay, this one I have 3 and 9 have a 3 in common. They would have 3 x's in common, which would give me 1 left over here, minus, I used all the x's, but I would have a minus 3. Okay, so greatest common factor you can actually use with no matter how long the expression is. If it had more terms than that, it would still work the same way. Okay, just as long as they have something in common. The last thing to look out for are things like this, that are let's do 36 x to the 4th minus 25x squared. Okay, this is a special type of equation because this is a perfect square and this is a perfect square. So when we have 2 perfect squares with a subtraction sign in the middle, we call that a difference of squares. Okay, so a difference of squares always works the same way. It's the same structure every time. Okay, you take the square root of the first term, so this is why it only works with perfect squares. Take the square root of the first term, 36, square root of 36 is 6. And then the square root of x to the 4th is x squared. We would divide by 2. And that goes in the front of both. And then take the square root of the back term. The square root of the back term would be 25x squared. Taking the square root would be 5x and 5x. Okay. And with a difference of squares, we always have the same thing happening. It's always a minus and then a plus. Okay? Because you can check yourself, if you multiply it back out, what's going to happen is you're going to have 36x to the fourth. You're going to have plus 30x cubed and then minus 30x cubed, which is why you don't have anything in the middle here. They go away. And then this one would give me negative 25x squared. Okay, so it only works with that negative and if these two are perfect squares, but that does come up pretty frequently, so be on the lookout for that. Once you did that, we could actually factor these further using some other methods, so we'll just look at that really quickly. Here, I have two terms. I don't have a third constant, so I wouldn't factor it like we did up here. I would look for a greatest common factor, and my greatest common factor would be an x. So I could turn this into x times 6x minus 5. And then here, I would also have an x in common, so I could do x and then 6x plus 5. Okay? And the correct way to write this is taking these two terms, multiplying them in the front here. I would have x squared times 6x minus 5 times 6x plus 5. And some of you might have noticed that from the very beginning up here, I do have a greatest common factor of x squared. So you could have taken that out first and then factored. Either way will work.